Dear students, welcome to JCE Connect, subject Engineering Chemistry. Yesterday we learnt about sewage treatment. In today's class, we will discuss how to convert hard water to soft water. The purpose of this conversion is to make water fit for our daily needs like drinking, cooking, agriculture and industries. The conversion of hard water to soft water is called softening of water, which is achieved by ion exchange method. Obviously, the hard water will contain salts of calcium and magnesium ions. Example, calcium chloride. If these calcium and chloride ions are removed or replaced with H plus and OH minus ions, then that water will be a soft water. The exchange is made possible by using ion exchange resins. These resins are nothing but cross-linked polymers with high molecular weight. They will have porous structure. The functional groups of these resins are capable of exchanging the ions. Two types of resins are used in this process. First one is cation exchange resin, filled in a column. Observe the column on left hand side in the diagram. This resin contains acidic groups which can exchange H plus or Na plus ions for calcium or magnesium ions present in hard water. The second one is anion exchange resin filled in another column. Observe the column on right hand side in the diagram. This resin contains basic groups which can exchange OH minus ions for Cl minus or sulfate ions present in hard water. Both the columns are interconnected. Students, now we will see how it works. Hard water is first passed through first column which contains cation exchange resin. Here the positive ions like Ca2 plus and Mg2 plus are removed from hard water and in their place the H plus ions are added. Refer the reactions given here. The calcium and magnesium ions remain inside the first column. Hence, the water coming out from first column is free from calcium and magnesium ions. Then, the water is pumped into second column which contains anion exchange resin. Here, the negative ions like Cl- and SO42- are removed from hard water and in their place the OH- ions are added. The Cl- and SO42- ions remain inside the second column. Observe the reactions provided here. Therefore, in conclusion, the water coming out from second column is free from Cl- or SO42-. Now, the water is free from all types of hardness causing ions and hence it is called deionized water or ion exchanged water. But after prolonged usage, the resins will lose their capacity to exchange the ions. Therefore, they are to be regenerated or reactivated. This can be done by following a procedure which is exactly opposite to that of ion exchange procedure described above. That is, the resin in first column is regenerated by passing a dilute solution of hydrochloric acid or sulfuric acid. Here, the H plus of the dilute acid replaces the calcium or magnesium ions and therefore these calcium and magnesium ions come out of the column. Similarly, the resin in second column is regenerated by passing ammonium hydroxide solution or sodium hydroxide solution. The OH- of base replaces the Cl- or SO42- ions and therefore chloride ion and sulfate ion come out of the column. go through the reactions given here. Finally, both the columns are washed with deionized water to remove the traces of acid and base. The ion exchange apparatus is user-friendly and hence it is easy to operate. Both the acidic water and alkaline water can be converted to soft water using this method. The hardness which remains even after conversion is negligible and therefore such water can be used for our daily needs. The major limitations of this procedure are if the water is turbid, then it needs to be filtered first before pumping to the ion exchange column. And also the ion exchange apparatus is a bit expensive since the resins are costly. Dear students, now we will try to understand how salt water or saline water is converted to drinking water. The oceans and seas are treated as reservoirs of water, but that water will be too salty in nature and hence cannot be used for drinking purpose. It is a good idea if we can lower the saline content or salt content of seawater so that we can use it for our daily needs. One of such method is desalination, wherein partial or complete removal of salt content is achieved. Hence, desalination is removing the salt content from water sample. It can be effectively carried out by a process called reverse osmosis. We have studied osmosis in biology. It is the physical movement of solvent from higher concentration to lower concentration through a semi-permeable membrane. When ordinary water and salt water are separated by a membrane, then the membrane allows only the water molecules to pass through it. Here, the salt cannot cross the membrane. During this movement of water molecules, a pressure is developed which is called osmotic pressure. If this pressure is applied in opposite direction, then it is possible to reverse the direction of movement of water molecules. This applied pressure is called hydraulic pressure. Here the condition is hydraulic pressure should be greater than osmotic pressure. This process is called reverse osmosis. Students, this is the schematic diagram of osmosis and reverse osmosis. The reverse osmosis unit consists of a synthetic membrane made up of cellulose acetate or nylon in a cylindrical shape. The seawater and pure water are taken in two different chambers separated by the above mentioned membrane. Since seawater exerts approximately 240 psi of osmotic pressure, the hydraulic pressure greater than this value is applied so that water molecules from seawater move to the other chamber through the membrane. Normally, the hydraulic pressure applied will be in the range of 400 to 550 psi. This is how salt water is converted to drinking water. Dear students, this completes fourth module. Thank you.